Okay, we're going to start with write the equivalent decimal and what kind of a decimal is it. So we're going to rewrite these as decimals and you're going to tell me what kind of a decimal it is. So we're going to start with 2/3. So we're going to T-bow this. So the top goes inside, bottom goes outside. There's a decimal at the end of 2. Bring it straight up, add some zeros. This next part's very important. How many 3's are in 2? None. How many 3's are in 20? 6. 6 times 3 is 18. 20 minus 18 is 2. Bring down the 0. How many 3's are in 20? 6. 6 times 3 is 18. Subtract 20. You can see what's going to happen here. It's going to keep repeating. So this is a repeating decimal. This is the decimal equivalent of 2/3, and the kind of decimal it is a repeating decimal. Number 2, we're also going to convert this to a fraction. 4 divided by 5. We're going to T-bow. 4 top in, bottom out. Decimal after the 4 and straight up. Add as many zeros as you want. That's still the number 4. How many 5's are in 4? None. How many 5's are in 40? 8. 8 times 5 is 40. No remainder. Nothing left to bring down but zeros. So this is a terminating decimal. It stops. This one stops after 1 digit. Okay. A square garden has an area of 81 square feet. A square garden has an area of 81 square feet. What is the length of each side, and what is the perimeter? So a square garden has an area of 81 square feet. So area, we know, is length times width. So the length times the width has to be 81 because they gave us that information. The area is 81. So this times this is 81. Since it's square, we know that the 4 sides are equal. So if this equals this, then some number times itself 2 times equals 81. Well, what number times itself 2 times equals 81? That number would be 9. So 9 is the length of one side. Then what's the perimeter? Well, since it's a square, the perimeter is all the sides added up. So if it's 9 and 9 and 9 and 9, 4 9s is 36, and it would be feet is the perimeter. Again, the area, length times width, is 81, and the perimeter is the distance around the outside. 9 and 9 and 9 and 9 is 36. Okay, what kind of a number is the square root of 27? What kind of a number is that? Well, the square root of 27 is irrational. Why? Because 27 is not a perfect square. Therefore, the square root of 27 is going to be some crazy irrational number. In fact, I know it's going to be between, let's see, these are the 2 square numbers just above and below it, so it's going to be between 5 and 6 on a number line, and it's going to be closer to 5, so maybe over here, so maybe something like 5.3 or 5.2, but in reality it's going to be 5 point something 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 something, which is going to be a never-ending, never-repeating decimal, because this is not a square number, so its square root's going to be irrational. Oh, this says estimate the square root of 27 to 1 decimal place. Well, we kind of started to do that, didn't we? It's between 5 and 6, and it's closer to 5, so I'm thinking maybe it's 5.2 squared. So that would be 4, 10, 10, 26, 4, 0, 7, 27.04 is pretty stinking close. It goes over just a little bit. Let's see what 5.1 times 5.1 is. That's 1, 5, 5, 25. This is 26.01. This one is actually closer to 27 than this one is. So 5.2 squared would be the approximate square root of 27, but it's really an irrational number. It's a decimal that goes on forever and does not repeat. Rewrite 2 to the negative third using positive exponents, and then simplify it. Rewrite 2 to the negative third using positive exponents and simplify. So 2 to the negative third looks like this. So we know we can put it over 1 and it becomes a fraction, and then if I flip it over, if I put this in the denominator, the base stays the same and the exponent becomes positive, and then this goes up here. So now we have 1 over 2 to the positive 3 power. Remember, when we raise something to a negative number, it's repeated division, and this number is going to get a lot smaller. And in fact, this becomes 1 over 2 times 2 times 2, which is 1/8. So it went from being 2 to the negative third power, that's equal to 1 over 2 to the positive third power, which is equal to 1/8. And now we're going to add these two terms together. 2.6 times 10 to the 5th plus 3.8 times 10 to the 4th. We're going to add these together. So the first thing you're going to notice, I hope, is that when we're adding and subtracting numbers written in scientific notation, their exponent has to be raised to the same power. And since this is a 5 and this is a 4, that means this either needs to become a 4 or this needs to become a 5. So what the heck, let's make this a 4. So I'm going to change this number to 10 to the 4th. Now, this number has to be equal to this number because it's going to replace it, but it's still part of this bigger problem. So these still have to be equal, they just have to be written a different way. So if I reduce this by 1, I'm going to increase this by 1, which means I'm going to move the decimal 1 space to the right. So this is 26 times 10 to the 4th plus 3.8, also times 10 to the 4th. Now I have to add these together. My exponent's the same, so 26 has a decimal at the end, and 3.8 has its decimal in the middle of the number. Make sure you line those little babies up. You get 8, 9, 2 times 10 to the fourth. Small problem. This answer is correct, but it's not written in scientific notation. So in order to write it in scientific notation, I have to move the decimal one space to the left. So this number got smaller, so this number is going to get bigger. This exponent's going to get bigger. This got 10 times smaller. This is going to get 10 times bigger because I want these to be equivalent. So this is your correct answer. This answer was correct, but this is your correct answer written in scientific notation.